Section 4.4. Properties of logarithms and logarithmic scales. Logarithm properties can be used to expand or condense a logarithmic expression. These come from properties of exponents. The product property tells us that the log of a product equals the sum of the logs. So whenever you see a log of something plus another log of something with the same base, you can convert that into a log of the product. This comes from the exponent property. If you have b to the x times b to the y, you have b to the x plus y. If you add two exponents, you multiply the expressions. So you add the exponents. Here the logs are the exponents. You multiply the expression. Similarly, the quotient property tells us that if you have the log of a quotient, that's equal to the difference of logs. This comes from the exponent property, that if you have b to the x divided by b to the y, that's b to the x minus y. If you subtract the exponents, you divide the exponentials. Power property, you have log of something to a power, that's equal to that power times the log. So if you have some exponential to a power, what do you do to the exponents? You multiply the exponents. B to the x times p. Since log is a function, if m equals n, then log of m equals log of n. Since log is 1 to 1, if the log of m equals the log of n, then m equals n. Let's do some examples. Let's expand these expressions using logarithmic properties. Here we have the log, the common log, base 10, of 100 over x, y to the third. When we're expanding logs, we look for the biggest operation that's happening. The biggest thing here is 100 divided by all of this. So we're going to use the quotient property. This is the log of a quotient, the log of something divided by something else. This is the log of the first thing, log of 100, minus the log of the denominator, log of x times y to the third. Remembering that the common log, the log without any base, has a base 10. What is the exponent on 10 that gives 100? The log base 10 of 100 is the number 2, because 10 squared is 100. Minus, here we have the log of something times something, x times y to the third. That's the next biggest operation. So we can use the product property of logs to expand the log of a product to the log of the first thing, the log of the x, plus the log of the y to the third power. Okay, put the minus out in front because it's minus this whole thing. This whole thing's equal to this expression. Now I'll distribute this minus. This is 2 minus log of x, and then minus the log of y to the third power. This 2 can't do anything with. This log of x can't do anything with. Minus, now we have log of something to the power. We can use the power property. The log of something to a power is that power times the log. So this has been expanded fully using properties of logs. Part 2, we have the log base 11 of x to the third times 5x plus 17. These brackets are just parentheses that are nested, so you can not get confused. Now to expand this, we look at what the biggest thing that's happening here. The biggest thing that's happening here is this multiplication, x to the third times this whole thing. You don't want to start inside, you can't do that. What's happening is this thing times this thing. So I'm going to use the product property. The log of this times this is going to be that same log, log base 11, of the first thing, x to the third, plus the log base 11 of the second thing, which is 5x plus 17. Here we have the log base 11 of something to a power, so I can take that power, bring it down, log base 11 of x. The power property, this exponent can come down as a coefficient. And what can I do here? The answer is nothing. This is just the log of 11, 5x plus 17, and we're done. Note, the log of x plus y isn't equal to anything cool. There's no property of log that talks about the log of a sum. Now let's go the other way. Let's rewrite these expressions as a single logarithm. So we're going to condense these logs. Here we have 2 times the log of something, so we can use the power property. This is the log of x to this 2. When you have something times a log, you can bring it up as an exponent. And then here we have minus, you have the log of y plus 3 times the log of z minus 1. We don't have a rule that lets us take the log of something plus 3 times the log of something else. So we first have to deal with this 3. So I leave this log of y alone and use the power rule here to take this 3 up as an exponent. So this is the log of z minus 1 to the 3rd power. Now I can use the product property. The sum of logs is the log of a product, so I leave this expression alone. And here I get minus the log of the first thing times the second, which is z minus 1 cubed. Now I have the difference of logs here. The difference of logs is the log of the first thing divided by the second. Y times z minus 1 to the 3rd power. So now I've condensed it to a single logarithm. Let's work on this expression over here. Something times a log, power property, log base b of x to the 3rd, minus power property, log base b of y to the 5th, plus power property, log base b of z to the 7th. Now that I got rid of all the coefficients, I can use the quotient and product property. Here we have the difference of logs, so that's the log of the first thing divided by the second. Then a plus a log base b of z to the 7th. Now I have the sum of logs. So that's the log of the first thing times the second. So when you multiply a fraction by a non-fraction, you multiply the top. So this is x to the 3rd, z to the 7th over y to the 5th.